Good day, everyone, and welcome to our Woman in Data Science Trinidad and Tobago Spotlight Talk. I am Dr. Leticia Addison, the ambassador of WiDS TT, as we call it for short, and I'm very happy today to have our presenter, Mr. Mithra Ramoutar. He is an agri-tech innovator, AI developer, and founder of CariAgri, and today he'll be talking about what CariAgri is in terms of a unified farming ecosystem. But before we get into that talk, just for those of you who are new here, to let you know that Women in Data Science Trinidad and Tobago is part of the global WiDS organization, where we build data literacy for all and also empower girls and women to lead and thrive in data science. So we host independent events aligned with the Global WiDS Data Challenge, building data literacy at every level while inspiring, empowering, and elevating girls, women, and the boys who support them in the field. All of our events are open to all data enthusiasts who are ready to explore the power of data. If you'd like more information on WiDS, please feel free to go to widstt.com, and you could follow us on our social media channels on LinkedIn as well as Facebook. So now for today's main event, I would like to give a short introduction to our speaker, Mithra. Mithra is a current Year 2 computer science undergraduate at the University of the West Indies. He is a very business-minded technologist, and he specializes in the intersection of AI, cybersecurity, and finance. And his background spans many research areas in sustainable AI. And particularly for our session today, he's looking more at local agribusiness and also really ensuring that the agribusiness sector has tools to help them with their entrepreneurship side as well. Beyond that, he is also looking to go into the more AI-driven agriculture space, and we're really happy to have him today to speak about the CariAgri tool. So, without further ado, let's get into our spotlight presentation. And Mithra, I will invite you now to share your screen and get into your presentation. And you can let our audience know a few things about yourself before you get started.
Right, go straight into it from there. Oh,
Yes.
okay. So, hi everyone, my name is Mithra Ramoutar. I'm a computer science student at University of the West Indies, St. Augustine campus. My background is technical. I work in software, data, and systems. And over the past year, I would found myself into a problem that sits at the intersection, really, of technology and something far more immediate, which is food security and our access to technology in the agricultural sector. So I've spent the better part of this year researching why Caribbean farmers can't access tools that the rest of the world takes for granted. And I've built a platform to address that issue, which is CariAgri. Um, the main question that I asked was, why are Caribbean farmers unable to access AI tools that are already transforming agriculture everywhere else in the world? And today I really want to share what shit was found, introduce a solution that I've designed and the built-in response to it. I'll give you a walkthrough of the technology infrastructure behind it and explain why this opportunity is worth serious consideration. So this is CariAgri, bridging Caribbean farmers to information. Right. So let me start first with the problem. 58.8% of the Caribbean population faces food insecurity. That figure comes from FAO's 2025 report. More than half the region cannot reliably access enough food, and the reason is not really complicated. We import 85% of our food here locally. The World Bank identifies the Caribbean as the most food import dependent region in the planet. And while we are importing food, our own farmers are losing around 20 to 40% of their crop every year. to diseases that could be caught and treated early. The technology to solve this really already exists, and AI detection systems around the world achieve over 98% accuracy at doing this. But those systems cost between $500 to $1,000 a year. And for a Caribbean smallholder farmer earning 6,000 to 8,000 annually, that is between 6 to 33% of their entire income per year. So the problem is not that the technology doesn't work necessarily. The problem is more that farmers can't access this technology. So I reviewed over 50 peer-reviewed academic papers from sources including FAO, the McKinsey Global Institute, World Bank, Science Direct, as well as interviews with local smallholder farmers and some local companies. And what I found was that the barriers to this AI adoption in Caribbean agriculture are not really technical, but they are more socio-economical and structural. I'd like to just show you, look at this data here. 95% of farmers identify costs as a barrier. 88% cite poor digital infrastructure. 82 cite low digital literacy. 79% cite a lack of trust in AI systems. And 71% point out that existing models are not trained on Caribbean crops. They are built for more wheat and corn and not really cassava and local crops. Now, that last point is critical. A globally trained disease detection model deployed in Trinidad will not perform well on cassava leaves as it does in European countries and on non-European crops. So the technology must be adapted to that. And that part is what CariAgri really does. So, ResNet 50, which is a standard neural nets architecture, achieves the 98% accuracy on these digital detection when trained on plant village data sets. TensorFlow Lite also allows the same AI to run offline on a basic Android phone in a package smaller than 50 megabytes, which is no internet required, totally offline. Transferred learning in this case means you do not need thousands of locally sourced images to build a Caribbean specific model. You could take globally trained models and fine-tune it with a much smaller local data set, essentially reducing data collection requirements by 80 to 90%. And yet, Korean smallholder AI adoption sits under 8%, and large commercial farms globally at around 38%. So that 30-point gap between this is technically possible and is what farmers are actually using. And that is the opportunity that CariAgri wishes to address. Another example of this is Digital Green, founded in 2006. It uses a WhatsApp-based advisory system. So they have documented 65 to 70% adoption rates and 18 to 25% yield improvements across countries like India and Africa. Another example is like Calro in Kenya, which delivers agricultural AI via SMS for less than $1 per month, which is around 60 to 70% seen adoption because of that in these targeted regions. One more example would be like Cedar, which has researched 12 to over 12 million farmers across these 27 countries. And they introduced something called Farmer.chat, which has developed a collaboration with MIT and universities in Canada. And it found that when farmers are involved in co-designing the tool, the adoption increases mainly because of that trust and that reliability of it. And the pattern across every successful model is really the same, is that it is affordable, it is offline and built with the farmers rather than just for them. And that was the main design philosophy behind CariAgri. Uh, So I would like to just address those 3 points that I just stated there of the successful business model and the successful model that farmers can adopt. The first pillar would be the technical accessibility of it. CariAgri main goal is to run offline. We use a TensorFlow Lite model to achieve this. It operates in under 50 megabytes on a basic Android phone. That is, disease detection takes only up to 2 to 5 seconds, and this addresses the infrastructure and the connectivity barrier. Another pillar would be the cultural and language space approach. The application supports Creole native interfaces. It was designed through a co-design methodology, which was farmer were consulted during the design and not just the deployment of it. So it positions extension officers in this part as partners, amplifying their reach rather than just replacing them and having an app just connect that and just do away with that area of field. Uh, our next pillar is the sustainable business model that I would introduce in a bit. The freemium entry point means that farmers start at zero cost. So things like crop pricing at $12 per farmer per year for groups make it very much affordable at scale. And government food security subsidies provide a runway in this early phases. And the last pillar would be the cybersecurity and data governance, a very important factor in consideration for this. So farmers get to own their data. The code is open source. Uh, as I said, GDPR standards do apply to it because it involves the agricultural sector, so regulations and standards must be applied. And also our algorithms are very much transparent. So every design decision is really made directly back to the research, and is also made with farmers in mind as well. Considering all this, this is where really our launch of CariAgri really stemmed from. It is a mobile-first agricultural ecosystem, not just a single tool, but 5 integrated modules into a one app. And it solves really the entirety of the farmer journey. So our one of the features is the AI crop doctor for instant disease diagnosis. We also have a marketplace where farmers can sell directly to buyers and cut out really middlemen that will upscale prices. And also farmer market intelligence, which is live commodity prices, the weather forecasts, and agricultural news, general agricultural news that could be specified to specific regions. We also introduced recently a digital wallet for payments online, where since you don't have the need for actual cash, and also an expert consultation hub for on-demand access to agronomists. So all of it is offline first. That is the approach that we took. And all of it is Caribbean specific. So it was designed around the barriers that we have researched and identified. So let me just walk you through the modules of this app. Our first module that we introduced and our main feature would be the AI crop doctor. So a farmer notices something wrong with for example, their cassava leaves. Historically, they would wait for extension officers to visit, or maybe visit the extension officer, and perhaps within a month, by then the disease would have spread to neighboring plots. That there is time that it could have been identified and treated and slowed down that infection rate, etc. So with CariAgri, it's simply the farmer just opens the app, photographs the affected leaf, and we have our own model as well as Google Gemini involved that analyzes the image within seconds and returns a structured diagnosis, such as the disease name, the confidence level of the disease that was identified, the severity of it, and also a description of what they are seeing. Then after, this is really the important part that we focus on. The app doesn't just identify a problem, but it also offers 3 distinct treatment pathways. One of them being the organic approach to it, another the chemical approach to it, and the preventive strategy that you could use for future seasons and future crops. So the farmer chooses what fits the situation and their budgets and their values. So every scan is saved privately to their history and based on comparable deployments, etc., like digital green and calendar. Models like this project are expected to yield 15 to 30% yield improvement and a reduction in the crop losses by approximately roughly 60%, down, say 60% to 10%. But like to be clear, this is a research-based project. So Caribbean specific validation exactly what our phase one of deployment on our roadmap is designed to generate, really. Our next feature, which is module 2, is the marketplace. So right now, when a farmer in Trinidad harvests cassava, they typically sell to a middleman who takes 30 to 40% of the value, and the farmer nets the equivalent 0.7%, well, that's 0.7 cents on every dollar we produce. So CariAgri marketplace allows the farmer to directly, well, photograph, weigh in kilograms, and etc. And it allows them to directly access the market and access buyers. And so they could get produce off their hand really, really quickly and cut down that spoiling rates, etc. And buyers would browse the listing by category purchase through integrated wallets and track their order from confirmation through this delivery. An example of this would be Seagull's direct trade research that documents that 26% of margin improvement are met when farmers sell directly to their buyers and to consumers. So this revenue engine for CariAgri through Marketplace Commission and a genuine wealth creation mechanism for farmers as well. So this model that we introduced was really meant for that to just cut out that middleman and have as much profit given to the farmer instead of it having taken away from them. Our next module that we introduced was the market intelligence. So market intelligence really gives the farmer the same real-time data that large agribusiness already have. So when a farmer opens CariAgri in the morning, they see the current commodity prices, for example, cassava, and they see whether they go up or down from yesterday and that price. They see the weather forecast for their specific location for the next 14 days. They also see the recent agricultural news for that region and for that crop, such as the new government subsidies. They also see pest control outbreaks, warnings, and market trends for that crop. They also have an income and expense tracker that shows them their farm's financial picture month by month for their produce. So for generations, Caribbean farmers have made decisions based on experience and word of mouth and intuition. That is usually the traditional sense of what's being a farmer and their intelligence accumulation would be. So CariAgri introduces this data to that decision-making process. The shift is really from guesswork to more data-driven farming, and we think that is really significant to yield produce, etc. The other module that we introduced was a digital wallet. So a digital wallet really solves the infrastructure problem. A substantial portion of the Caribbean smallholder farmers do not have formal bank accounts, and this creates a practical barrier to that digital e-commerce. So a barrier wants to pay electronically, but the farmer has no way to receive it, essentially. So every CariAgri user here receives a wallet on registration. They can deposit funds, receive marketplace payments, and pay for expert consultations all within one app. Every transaction is recorded for their convenience, and every movement of money is handled on the server side, which means it cannot be manipulated by the client. Well, to back this up, World Bank documents a 15 to 20% income increase for the smallholder farmers who gain access to digital financial services, which makes your wallet more possible and more convenient to farmers. as I mentioned just now, the other module that we introduced was the expert consultation module. This addresses really that problem that extension extension officers face directly, which is they can't in the time period to access an extension officer is rather long. And not only that, the farmers usually reach out to companies to set that up, and then that takes a lot of time when it says their crop needs immediate attention. The FAO's 2025 data shows that extension officers, the extension officer to farmer ratio in the Caribbean exceeds 1 to 200, which means one officer covering more than 200 farms locally. So, and that visit happens like once per month. So farmers make the vast majority of their decision without that expert input and reliance on traditional practices. So what CariAgri intention is to connect farmers with vetted agronomists and veterinarians. So they can browse by specialty, see ratings of other farmers, and book a consultation essentially for a specific date and time. And while the payment for that, etc., is done through their wallets directly in the app. So they can access these extension officers immediately and directly and get feedback within a couple of days. But note that it isn't necessarily to replace the extension officer. What we're doing here is opening up more opportunities for these professionals and extending their reach essentially. What I'd like to cover next is the infrastructure of the app. So the front end is built using React Native with Expo. This means that there's one code base that compiles straight to iOS, Android, and the web simultaneously. So one developer can maintain these platforms from one code base. The backend of it runs entirely on Superbase, an open source platform that really provides that database and post SQL and user authentication and other things like file storage and server-side edge functions from one platform. We also implemented a role-level security that's enabled on every table. So a farmer history is private to them. A wallet, transactions, etc. can be written by the server and never the client. And the security model itself is pretty robust, but it's there to ensure that our farmers are well kept and that their history and their information is private and secure. The AI that we use is powered by one of our own models that we introduced, as well as Google Gemini. So we introduced a true teachable machine, a new model that identifies the disease. And from there, it's routed to Google Gemini for current market trends and current chemicals that are on the market that a farmer could use. But the actual identification of the disease is done through our own model that we created. So the API key lives entirely on the server side, and it is never really exposed to the application code. Our web deployment is done through Vercel. Our GitHub repository is also there. So the web version updates automatically in under 2 minutes. And our mobile builds are compiled through the Expo's EAS service and distributed via Google Play. Our intention is to also have it on Apple test flights, but that is still in progress. So the infrastructure is at production grade. It is meant to be scalable and built with really that security as a first principle and the thing in mind. What I want to touch on in practical terms is the data flow, how that works. So when a farmer photographs a crop, the image is uploaded to a Superbase storage. The URL is passed to Google Gemini and our model as well. So it'll pass our model first, have the identification done, pass to Google Gemini for the chemical trends, the crop trends, etc. And well, this is done by our server-side edge function and is never directly from the app. All of this would be server-side, right? And Gemini would retain a structured JSON diagnosis of it, and the diagnosis saved to our database and diagnosed and well displayed to the farmer. So that total time of this diesel process would be around 3 to 5 seconds, depending on connectivity, and also if it's up to date offline. So every step is also logged, and our transaction is auditable. So every piece of farmer data is really protected by our database level security rules that we have implemented here. The security model also. So really on the security specifically, what we introduced was rule level security, which means that no user can see another user's data. This will be enforced at our database level, so not just the application level. So wallet transactions are server-side written only. Things like farmer scan data is private by default, and sharing is not allowed, essentially because of our rule level security. So the principle is really simple, is that farmers' data belongs to the farmer, always. And that is one thing that we had in mind while building this. So moving on to really the business model of it. Um, the business model is designed with resilience in mind. The five revenue streams that we have is no single dependency. So our marketplace commission on every transaction is like 5 to 10%. We have premium subscriptions where farmers can access, well, all the advanced features of it, which is $10 to $20 per month for that subscription. Our commission on expert booking would be like 15 to 20%. And we also think that government subsidies that we had in mind. It's still in progress, but that Caribbean government's view should be that they are actively seeking out solutions of this kind. So we try to connect that to farmers directly. And our data monetization, where farmers who often to receive a share of revenue from anonymized insights. So we would have the farmers themselves giving us real data that we could use that is backed. So our hope is that year one, what we're trying for is year one to have 500 active users, where we project approximately like 150 in revenue, 150K in revenue, and year three at 50,000 users with regional scale, etc. We project as maybe 2.5 million within that 3 year. Yeah, now this has been a bit pessimistic because it is a large field. It is a really big market right now. So it's been a bit pessimistic, but we still need to keep in mind a couple of factors when doing some getting this approach. Now, this would be like transparent with numbers. Year one revenue is really heavily dependent on our premium conversion rates and our outreach to farmers, because we hope to reach more farmers through our workshops and so on in our initial deployments. And year three projections assume that successful regional expansion. So the unit economics improved significantly at scale, and customers acquisition costs dropped from 300 in phase one to approximately $50 by year three when successful scaling. How the roadmap to this would look is pretty practical and phased. Phase one, we're looking at 75 farms in Trinidad here, mainly on cassava and cocoa, although the app is capable of a lot more than just that. Those are the main crops that we look at. And the goal is Caribbean specific validation data. So like yield improvement, satisfaction, cost benefit, those factors. And it will be like funded, etc. So phase two of our deployments would be more that'll be like 4 to 6 months where we're hoping to incorporate 500 farmers across Trinidad, and other countries like Barbados and Dominica, where we have the marketplace live and we also have well contracts and so on to get this phase out. And our last phase will be really the scaling phase, where we really focus a lot on scaling. This will be like month 7 through 12. Being a bit optimistic about month 7 through 12. And our goal is to have 3,000 plus farmers incorporated onto the app. And by this point, well, revenue would cover our operational costs and all these platforms, self-sustainability. So we would be at that point just focus on reaching out to farmers, scaling, and getting this app across. So the modular design really meant for every island can have a customized configuration and so on for local crop models and local language support and also local pricing as well, without having to rebuild the platform from scratch. So I would like to just create a demo of what our beta version of CariAgri right now. So this is a home screen of it. This is current data and current market trends as we have with specific crops, etc. So on the homepage, you can see the weather for that specific region right now is tailored to Trinidad, but the weather for the next week. We also have the commodity prices of the crop that you would have. So whether that stock went up or down for that day, so it'll wait within the 2 days. We also have live news. So this would be like from CariWire, Farm Journal, Market Line, also like CariTech today. Those sources. We'd have them here on the homepage that you can view and see the trends that currently happen with specific crops, etc. And at the top, you can see three modules here, which will be the first one I would want to introduce is the scan crop feature. So what you could do is that you could take an image. Well, right now, since the beta, I'll just upload a file. Um, right, so you would upload an image, and from here, what it will do is our teachable machine module with will analyze it, identify the disease, direct it to Gemini, and have that um the severity, etc., displayed to the farmer. So yes, as you can see here, it'll show the severity of the disease as well as the confidence rates right below here, identification as well of what the disease is. You have the organic approach to curing the disease, as well as a chemical approach to it. So these are chemicals that are on the market right now that a farmer could purchase to treat the issue, as well as preventative measures as well that they could take for future instances of it. The other feature that we have is the marketplace. So here a farmer could upload their crop and well their yield and upload the price and etc. The rates, the weights, all these things. And a consumer could directly access this and well the different categories and access essentially what the crop is, well what essentially they want and buy directly from the app here. So this was really the initiative of connecting that farmer directly to consumers. The other feature that we introduced was the experts feature, which is consultant hub. So these are not real people, right? This is the base version. This is examples of what it would look like. So registered agronomists and veterinarians could come here and put their services there for farmers to access directly. And well, through this they could make a consultation booking and have a extension officer directly accessible to them and to their farm within a couple of days through this feature. On the profile, well, anyone who registers, you could either identify as a farmer upon registering, a farmer, or a buyer. Now, farmers have the option of switching over to a buyer if they want to if they want to purchase on the marketplace. But you also have the option of both, but that's mainly for farmers. Um, and from here you have the Go wallets where you could view the current deposits that you have on the wallet, as well as orders, past transactions here. The listings that you would have, this would be for all the transactions as well as bookings. You could actually have here too the bookings that you'd have with consultants, as well as the history of all the past diseases that you would have scanned, and well, all scans would be also listed here as well. And you could also view the current stock rates for different companies as well as your expenses, your incomes, all these things can be tracked through the app itself. And well, simple entry from here. You can just add in an expense or an income, etc. to track all these things from the app itself.
Well, that is a really, really interesting look at the app. Thank you very much for that, Mitra. And I'm quite sure that a lot of people would be, especially as you see farmers and veterinarians. I really like that you have all of these persons, the experts in this space as well, and have that kind of community level interaction that I think is really, really important for this type of tool. And I'm hoping that, you can see this flourish in terms of what your presentation said with getting the specific investments, etc. And maybe any last words before we end off the session today that you would like to tell the audience?
Um, yeah, last would really be to look at farming. Well, farming is the pinnacle of any country. It's what consumers
Well,
depend on. So look at it not just as a commercial opportunity, but just look at it as a community and a central part of um every single ecosystem, essentially.
good, and I'm sure our audience will be very happy to hear that, especially any of the budding entrepreneurs and technical experts that we have. So really want to thank you very much today, Mitra, for this presentation. And I will provide Mitra's contact in the description for the video. So if you want to contact him to find out more, to have a demo, to carry, to some of your farmers or technical persons in the community or investors, you can feel free to do so. So thank you everyone for joining us for the Spotlight Talk, and we will see you in the next one. Take care and bye-bye.